Hey guys, welcome back. Module 6, Lesson 4. Today we are going to be using meters to model the decomposition of one whole into hundredths and then represent and count hundredths. We will be drawing a lot of tape diagrams that represent a meter stick today, so you'll get really good at taking a rectangle and breaking it into tenths. Alright, here we go. I am going to cheat and use my rectangle tool. Alright, and then I'm going to go ahead and break this into tenths. They're not perfect, but they're okay. And then I'm going to go ahead and label this as 1 meter. Remember, meters are a type of metric measurement. Alright, so just kind of talking for a second here about a meter, since I'm not up in front of you, in front of the classroom, holding a meter stick. Now, a meter stick has 100 centimeters. Okay, so 1 meter equals 100 centimeters. But as you can see, my tape diagram is not modeling that. I only have 10 spots there. So what that's showing is that each one of these represents 10, 10, 10, 10, 10, and so on. 10 groups of 10 would be our 100 centimeters. So each one of these boxes represents 10 centimeters. Okay? Altogether, we have 100. The reason I broke this down into 10 is because it would get quite challenging to make 100. I mean, guys, that would mean I'd have to make 99 lines. And I'm just, quite frankly, not good at that, number one, and it would get really sloppy. So just remember that 1 meter equals 100 centimeters, and that we are not going to sit here and draw 99 lines so that we have 100 little rectangles to show that 100. Because that would mean, if I were to model that real quick, that would mean that I would need 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? And the only reason I did that slightly okay was because you can't tell on your end, but I was able to zoom right in on that and draw my 9 lines. And then if I kept going and did that in my next box, 1, 2, 3, 4, 5, 6, 7, 8. I'm going to count that last line I have there as 1. Okay? Now I'm up to 20. And if I kept going, I'd have 30, 40, 50, 60, 70, 80, 90, and 100. But that's just a lot of work. So we're not going to do that. So each one of these boxes represents 1/10 of a meter. But each one of those little teeny guys in there represents 1/100th of a meter. Now, we represent those in 2 different ways. 1/100th looks like this. Okay? And we represent 1/10 as 0.1. So much different than the 1/10. You'll notice that this is in a whole different place. A whole different place. Now, what if I said to you, I'm going to grab a different color. If I were to shade this box, I want to know, what does the shaded part represent? What does the shaded part represent? Let me just get rid of some of this so I have a little more space here. So I'm asking you, what does the shaded part represent? Well, there's 1/10, okay, so it can represent 1/10. But there's also 10 little guys shaded. But if you're referring to the 10 little guys, you have to remember that there's 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So that's 10 out of 100. Now, how would we write that as a decimal? If 1/10 is the same as 10 100ths, that means that 1/10 is the same as 10 hundredths. Okay, this is really important to understand. Just because I have that 0 right here, it doesn't actually change how much is shaded. 1/10, 10 hundredths. If I were to cross off that 0, I'm still left with 0.1, 0.1. Those are actually the same decimals. We say them a little different. Alright, let's try another one. My problem is I don't want to erase my tape diagram, but I won't be lazy. I will draw another one. Of course, I can cheat and make a rectangle anyways. Alright guys, and you guys have to make one, so that's only fair of me. Go ahead and split that in half. 1, 2, 3, 4. 1, 2, 3, 4. Alright, there are my tenths. Now I'm going to go ahead and shade. And then I'm going to 1, 2, 3, 4, 5, 6, 7, 8, and I'm going to cheat and do one more at the end there, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Alright. And then I am going to shade, but I'm going to use a different color so you guys can see. Okay, I shaded 6 of them. So if you guys need extra time to create this tape diagram, go ahead and push pause and finish drawing it. We're going to label that as 1 meter. Okay, here we go. We are going to use the model with the shaded parts, and then we're going to write it in decimal form and create an addition sentence to go with this. Noticing that the whole thing is a whole, I have 3 shaded and then I have 6 shaded. We have to determine what the fractions are when writing this down. So going back to what we just did, each one of those represents a tenth. But if you zoom in and look at your tiny little rectangles, okay, those represent tenths, or sorry, hundredths. No longer tenths, those are hundredths because there's 100 of them in a whole meter, 100 in a centimeter. Each one of those represents a centimeter. One whole box, though, represents 10 centimeters altogether. So I have 10, 20 centimeters, 30 centimeters, okay? Or 3/10 of a meter. Plus, I shaded 6/100ths of a meter here because I'm only talking about those centimeters. That is going to equal 36 hundredths. Really, it's 36 centimeters. I have 10 centimeters, 20 centimeters, 30 centimeters, plus 6 more is 36 hundredths. Now we are going to rewrite that as a decimal. And this is simply going to be, there are no holes, okay, right? I have a meter stick here. Did I shade a hole? No, I did not. Not even near half of a meter yet. So I have 0 holes, 0 ones. I have 3 tens. Here's my tens. And then I have 6 hundredths. 6 in my hundredths place. 36 hundredths of a meter. I'm drawing everywhere here. 36 hundredths of a meter. Now if I were to break that down into a number bond, because you will have to do that on your problem set, 36 hundredths, because the 6 lands in the hundredths place, we're going to break that down into tenths. There are 3 tenths, and there are 6 hundredths. Alright guys, you're going to give this a shot on your problem set. They're really going to start by asking you to determine the difference between tenths and hundredths and being able to recognize that 10 centimeters is 1/10 of a meter. And that one little centimeter is 100th of a meter, because you need 100 centimeters to make a whole meter. So one little guy is 1/100, or 1/100th of a meter. Now, if you're really struggling with this, I suggest that you really work with your partner to figure out how to complete it. And if you and your partner are struggling, please come and see me or Miss Driscoll. Okay, good luck.